Right? We said lines of parallel gradients are equal. So we must get it in standard form. How do we get it in standard form? By making the y subject of the formula. So we take the 4 over, so y is equal to negative 4x plus 3. So your gradient 1, the first gradient is equal to the second gradient, in this case is equal to negative 4, lines are parallel. You see that, people? So what do we say? Y is equal to negative 4x plus c. So what do? We'll sub negative 1 and 7, x and y. So it's going to be 7 is equal to negative 4 times negative 1 plus c. That is positive 4, not so? Take it over, it becomes 7 minus 4 is equal to c. So c is 3. By equation, y is equal to negative 4x. Okay, any confusion here, people? No. See how much time I'm spending on this? Because it's very important to understand. Okay. Next one. If lines are perpendicular. What do we know if lines are perpendicular? The product of the two gradients is negative 1. But you cannot read the gradient as it's lying here. No, it must be in standard form. What is standard form? Y equals mx plus c, where m is your gradient. Right, so what do? You must first make y the subject of the formula. So it's negative 2y equals negative x plus 8. Divided by negative 2 throughout. So y is equal to a half x minus 4. Now what do? You can now say that gradient 1 times gradient 2 is equal to negative 1. Why is that the case? Because lines are perpendicular. Okay. So the first gradient is half times the second gradient is equal to negative 1. Divided by half both sides, so m2 is equal to negative 2. Have I answered the question? No. Just move this down again. Alright. So, therefore, my equation now reads y is equal to negative 2x plus c. Can I read my c value off from here? No. Why? So x is not 0. So in other words, I'm going to substitute a half and 3. Half and 3 into the equational statement. So again, that's an x and a y. So I have 3 is equal to negative 2 times a half plus c. What's negative 2 times a half? Huh? Negative 1. You bring negative 1 over, it becomes plus 1. So 3 plus 1 is 4. Therefore, y is equal to a half. No. Y is equal to negative 2x plus okay, any confusion, people? No. Alright. Okay, as you can see, I need the space. So I'm going to take this off here. Now we're looking at 15F. Okay. Sketch, not draw to scale. The question says, determine the equation of the following graphs. So what do you notice here? You've got the two coordinates. You have an x and a y coordinate. X intercept and a y intercept. So what is the coordinate of this point here? 0 and 6, yes? And the coordinate of this point? Negative 3, and you are familiar now, yes, anyway. Not so? So let's go. y is equal to mx plus c. To work out the gradient is y2 minus y1 over x2 minus x1. So the gradient is going to be, if I make this x1, y1, x2, y2. So it's going to be 6 minus, no, I made 0, y1, so it's 6, 0, minus 6, over negative 3 minus 0. Now before I go and calculate that, is this gradient going to be positive or negative? Positive. Why? It's increasing. The graph is lying to the right. Yes, it's increasing. So negative 6 over negative 3 is 2. So the slope of this graph is 2. So y is equal to 2x plus c. Do I have my c value? Do I know my c value? Yes. What's your c value? 6 is your y-intercept. So y is equal to 2x plus 6. If you didn't know that, at that point you'll either substitute negative 3 and 0 or 0 and 6. Okay? Let's look at the next question. You all okay? That's going to be the same. Alright, so write your equation here. Y is equal to a half x minus 2. Okay? Let's go to the next worksheet, next question. 1.3. Okay, again, in this I'm going to do the odd numbers, so this is the 1.3. What's the coordinate of this point? 0 and 4, which is also your c value, your y-intercept. Not so? C value is 4. And this coordinate here? 3 and 0. So remember now, y is equal to mx plus c. To calculate m is y2 minus y1 over x2 minus x1. You see me writing these formulas down all the time. Right? You will be so, it should become second nature to you already. Okay? So you're seeing the things and you're writing it down all the time. Okay? So that is x1, y1, x2, y2. Okay? So for the gradient is y2, which is 0 minus 4 over x2, which is 3 minus 0. Is this gradient positive or negative? Negative. Why? It's decreasing. It's lying to the left. Okay? So it's going to be negative 4 over 3, which confirms my assumption. And what's your c value, people? 4. Okay? Next. What do you notice here? It's going, you got 2 points. But what is the coordinate of this point? 0 and 0. Change in y, change in x, the same story. Okay? So y is equal to 3 over 2x. Okay? As we did before, it's going to work out the same. Okay? Let's go for 1.5. As it is an odd number. So do we have 2 points on this graph? Yes. What's the coordinate of that 1 point? X is 4, y is 1. Does this make sense? So we go. Y equals mx plus c. M is y2 minus y1 over x2 minus x1. The coordinates here is 4 and 0, and the other coordinate is 0 and 0, which is your origin. Okay? So if I make this x1, y1, x2, y2, is this gradient going to be positive or negative? Positive. What is your c value? What's the c value? What is the y-intercept? 1. What's the y-intercept? 0 is. So your c value is 0. So you say a gradient is equal to 0 minus 0. Nope, I made a mistake. It's 4 and 1. It's coming from me. So 0 minus 1 over 0 minus 4, which is 1 over 4. So y is equal to 1 over x plus c, and your c value is 0. Okay? Let's look at the next one. (1.6). Okay? The gradient here, the gradient is 45. Sorry, the angle of inclination is 45. So if that's the case, what happens is, we have done something like this before in the exercises or in the introduction to it. But what you notice is if that is 45 and you draw a 90-degree triangle, we're going to now form an isosceles triangle. Why? Because the angles in the triangle adds up to 180. So if that distance from there to there is 2, then that is also going to be 2. If this is 20, then that's also 20. Because that's an isosceles triangle. Not so? If this is 120, 120. 1200, 1200. So the rise and the run is the same. So your gradient is going to be 1. Does it remember that? If it's a 45-degree angle, the gradient is 1. If the angle is 135, and then what is the gradient there? Negative 1. Okay? We've done this when we did initially when we did the graphs, the introduction to it, we spoke about it. Okay? So what's my equation? Y is equal to mx plus c. So y is equal to m is 1, x, and what's your c value here? Do you see value? What is your c value, people? Not 0. People on the other side will think it's something wrong with that. Huh? What's wrong? You okay? People, the equation of this line? Just negative 2. 0 and negative 2? X is equal, yes. X is equal to negative 2. We did a few of that now earlier on. That's when you probably blinked. You remember we did it? Right, next. 5f. No, still busy with f. Rise and run. Is this going to have a positive or negative gradient? Sorry? Negative is decreasing. What is the rise? 1. And the run? 2. Change your marker, change it. So, this is your c value here. What's your c value? 1. So what's the equation? Y is equal to negative of x plus 1. Okay. Come, please don't get this one wrong. 1.9. What? X? Oh, you said not x. Oh. Y is equal to 3. Almost gave me a shock. People, 1.10. 1.10. Right? Do we have two coordinates here? No. This one, we have 0 and 1. And 3 and negative 1. People, this one, we have done many like this before. 1.10. The answer is y is equal to 2x plus 1. No, y is equal to negative 2 over 3x plus 1. Okay? 1.11. Again, y is equal to mx plus c. I'm doing it because that's odd. Y is equal to mx plus c. The gradient is y2 minus y1 over x2 minus x1. Okay? If I make this, what's the coordinate here? 0 and? No. Negative 1 and 0. And 1 and 4. Again, if that is x1, y1, x2, y2. So the gradient is going to be 4 minus 0 over 1 minus minus 1. Is this a positive or negative gradient? Positive. It's increasing. So 4 over 2 is 2. What's your y-intercept? Do you have the y-intercept here? No. So I must use one of the points. So y is equal to 2x plus c. We substitute negative 1 and 0. That's an x and a y. So 0 is equal to 2 times negative 1 plus c. That's negative 2. Becomes positive 2. Does it make sense that this is positive here?
Yes.
Yes, it's above the x-axis. So you say y is equal to 2x plus. Okay, any confusion here? No. Next. 1.12. 1.12, I have an equation of y equals negative x plus 5. 5 if number 2. Right, now the stuff is getting exciting. Okay, we were busy with all that boring stuff. No? Now it's getting exciting. Now we have more than one graph on the axis and all of those. Many of you are seeing it for the first time. Looks like it. No, you didn't do your homework. You will show you didn't. Your own detriment. No? Sure. Right, determine the equation of f and g in each of the following graphs. People to calculate f, let's go with f first. Do we have 2 points? Yes. So, what's the coordinates of those points? 3 and 0. And 0 and negative 2. So it will be in the form of y is equal to mx plus c. For m, y2 minus y1 over x2 minus x1. So that's a x1, y1, x2, y2. Alright. So we say your gradient is negative 2 minus 0 over 0 minus 3. Is this gradient positive or negative? Positive. The graph is increasing. Negative 2 over negative 3 is 2 over 3. Do I have the y-intercept? Yes. So the c value is negative 2. Can you see that? So y is equal to 2 over 3x minus 2. Now you see there's a f there. You see the f? So this is the f of x equation. Can you see that, people? This is another name of it. F. Just naming the graphs. We'll do more functional notation in grade 10. You see that, people? So there's a f and there's another other graph g. Right. So for g of x, what do we know about g of x? We have a y-intercept. So the c value is negative 1. This is it put here for g of x. Your c value already is 1. Not so? But what else do we know? These lines are parallel. These lines are parallel. What do we know? Gradients are equal. So the gradient 1 is equal to the gradient 2, which is 2 over 3. Why? Because that was the gradient of the other graph of f. Can you see that, people? So y is equal to 2 over 3x plus 1. Okay? 2.2 is different, so I'm going to do it. Bit different. So to calculate the grade for f of x, oh yes, I forgot to put g of x here. No? Don't forget to put g of x is equal to. Okay. What if they ask you to work out g of 5? Did we ever see an x up with that? 5. Can you see that, people? And then that would have given you 10 over 3 plus 1 is 13 is 14 over 3. Okay? Yes, you get the sum again. Okay, now you must take notes. You're going to get, listen, you're going to get all of this. What did I tell you? G of x is equal to 8. What? Shh. Let's say G of x What if g of x was equal to 8?
Substitute 8.
Yes! Wherever you see that, you substitute 8 here. So 8 is equal to 2 over 3x plus 1. So you take it over the equal sign. So it becomes 8 minus 1 is 2/3. It's going to give you 7 is equal to 2 over 3x. How do we get x on its own? Divide by 2 over 3 both sides. Just like we had in equations. So it's going to be 21 over 2. Okay? So know what to do, people. Know these things. Right. 2.2. For if do we have 2 points on this graph? Yes. There's 2 points. What's the coordinates of those points? Negative 3 and 0 and 0 and negative 2. Okay. So remember again, if this is x1, y1, x2, y2. So it's going to be y is equal to mx plus c. What's our c value? Negative 2. Why? It's your y-intercept. Not so. For m, how do you calculate m? y2 minus y1 over x2 minus x1. So it's going to be negative 2 minus 0 over 0 minus 3. Which is negative 2 over 3. So therefore y is equal to. So if lines are perpendicular, what do we know? The product of the gradients is negative 1. So gradient 1 times gradient 2 is equal to negative 1. What's the first gradient?